Okay, so we have now our next speaker in this second section, Chris Sainty. Hi, Chris.
Hello,
Hey,
how you
Chris.
doing? Hi, good morning.
And as we wait for your wonderful presentation, I will just use a minute to remind you that to the right from your player you have a language switching button. You can listen to the English original track or interpret it into Russian. Don't forget to pause the other stream, otherwise you will just listen to both streams and that would be confusing. So Chris, you have the floor.
Cool, thank you very much. Let me just sort my screens out quickly. Lovely, so good morning everybody, and welcome to my talk on building next generation apps with Blazor. Let me just quickly introduce myself. So my name is Chris. I'm a principal software developer at Deployed, who are a startup based in London. I'm a Microsoft MVP. I also do a lot of blogging on my blog at chrissainty.com. But currently, I'm putting most of my efforts into writing a new book called Blazor in Action for Manning. Any other spare time I have, I spend doing open source work, and I maintain a set of open source packages under the GitHub organization Blazor. Cool. So that's enough about me. In terms of today's talk, it's going to be a very code-heavy talk. I'm going to show you a few slides. I'm going to give you some basic information about Blazor, and then I'm going to just get into some code. I'm going to spend the majority of the next hour in Visual Studio actually writing a Blazor application and getting some first-hand experience of what it's like to use the framework. So I'll start off with the basics first. So what is Blazor if you're new to it? Well, Blazor is a component-based framework for building interactive UIs. Essentially, you can think of Blazor as the .NET equivalent to Angular or Vue.js or potentially even React as well. That is what the goal of Blazor was originally. It is to be a direct competitor to those JavaScript frameworks. Now, what's really interesting about Blazor is it has a very well thought out architecture, and it has a separation between its app and component model, which is essentially how applications are written, and where the application is actually run, which is its hosting model. Now, what this means is that Blazor can actually be really flexible, and we can use Blazor potentially for a lot of applications. So today I'm going to be talking to you about using Blazor to build web applications specifically. But because of this architecture, there's some ongoing experiments with Blazor. So firstly, there's an experiment to see Blazor working on a desktop environment, and that's originally was using Electron. But since then, there's been another version of this where Steve Sanderson created a new technology called Web Window, which is essentially Electron on a diet, and Blazor also works there. And then there's also mobile Blazor bindings, which is an experiment to see Blazor working to create native mobile UI. And this sits on top of Xamarin Forms technology. Now, like I said, I just want to reiterate both of these ones on the sort of the middle and the right here. They are both experiments, okay? They're not production supported. They're not committed to. They're just kind of Microsoft feeling out, seeing how far they can push this technology. But as I said, today we're going to be talking about the web versions, and there's two web hosting models for Blazor. There's Blazor Server, and then there's Blazor WebAssembly. So Blazor Server is a hosting model where your application actually runs on the server in a similar way to Razor Page or MVC applications. The interesting thing about this, though, is there's a SignalR connection set up between the client and the server, and all of the UI events and any UI updates are transmitted back and forth over this SignalR connection. Now, what this means is that Blazor Server it's very small and it's very fast to start up because it doesn't have to download much to the client. You also get pre-rendered apps by default with Blazor Server, which can be useful if you're doing SEO. You get access to the full .NET framework because you are running on the server, so you get access to everything you had before. And you also get very good code security because your application is executing on the server, your code is staying on the server, only small UI updates are being sent down to the client. However, in terms of trade-offs, this does mean that you have a heavier load on the server. The server has to keep track of all of these clients that are connected to it. It also means that because of this Signal R connection, you do need to have a constant connection to the server. If there's a connection blip, if the connection is dropped for any reason, then the application will freeze and it will need to re-establish the connection before the user can do anything else with it. And that also means that latency has a big effect. So if you've got a large latency between your client and your server, then the UI is going to feel laggy. Tests show that about a 200 millisecond latency is about the most that you can have before the UI starts to show degradation. The other hosting model is Blazor WebAssembly. Blazor WebAssembly is the one that most people get quite excited about because this is where C# code is executed directly in the browser using a new technology called WebAssembly. So WebAssembly is a web standard. It's officially the 4th language of the web as of December last year. And what happens with this hosting model is the .NET runtime, the mono.NET runtime to be precise, is compiled down to WebAssembly. All of your application's DLLs are downloaded into the browser and they're executed using an interpreter in the browser. So the benefits here is that everything is running client side, so you can offload a lot of that work to the client. This is a true replica of the JavaScript SPA frameworks. It's really easy to make Blazor WebAssembly apps into PWAs because everything is running in the browser. You just need to make calls back to your API to get some additional data perhaps. But if you're running something like a game that doesn't need to go back to the server, or some simple application like a to-do list potentially, you can work totally offline. The other great thing about Blazor WebAssembly is if you're using a Blazor WebAssembly, a standalone Blazor WebAssembly application, it's actually compiled down to static files, which means you can deploy it as static files. This means that you can use free hosting services like GitHub Pages or Netlify, or nearly free like Amazon S3 buckets or Azure Blob Storage to host your applications really cheaply. And the other major benefit for Blazor WebAssembly, if you're a .NET developer, is the code sharing functionality. So because it is .NET code, you can share classes between your front end and your back end just using a normal class library. As I said, this is probably one of the biggest benefits if you're a .NET developer and you're using .NET on your back end. One of the biggest hassles with using JavaScript frameworks is having to translate DTOs from your back end into TypeScript models or JavaScript representations. So this gets around that entirely, which is great. However, there are some trade-offs. So because stuff is being interpreted in the browser, it means it's quite slow for CPU-intensive tasks. So if you're doing a lot of CPU-intensive work, Blazor WebAssembly will be less performant than other runtimes. And also, you do have a larger initial download with Blazor WebAssembly. You are downloading an entire .NET runtime after all, so there is a bit of an initial cost there. Two things here. Firstly, that cost is only paid once. Once you've downloaded it to the browser, it is cached, and therefore on subsequent loads, the user doesn't have to pay that cost. And secondly, it's not too bad for what it is. There's IL linking, which is a technology which strips out unused code during the build process, and that shrinks things quite dramatically. And the whole .NET runtime is around 600K at the moment. So that's it for the slides. I wasn't joking. This is basically all I'm going to show you in PowerPoint. And what I'm going to do now is I'm going to drop out of PowerPoint and we're going to go over to Visual Studio, and we're going to actually look at the application we're going to be working on for the rest of this talk. So here we are over in Visual Studio, and what I've got here is a solution that is a .NET, is a Blazor WebAssembly, and it's an ASP.NET Core hosted version, which basically means we have a Blazor WebAssembly application and we have an ASP.NET Core Web API project, and we also have a shared library to share code between them. So that's what this client server and shared project are for. So I'm going to talk you through the structure of this in a second, but firstly, I'm just going to show you what we're working with. So this is the application we're going to be working on today. So this is Blazor Repairs. It's a fictional repairs company, and they've got this really simplistic app that we need to improve. So at the moment, we have this dashboard page that doesn't have anything on it. We have a new repairs page for adding new repairs, but that's not been built yet either. In fact, the only page that actually has anything on it is this view repairs page, which just lists out some stuff that's already in our system. But that's about all it does. So what we're going to do over the course of the remaining hour is we're going to look at three major parts of Blazor. We're going to look at doing forms and validation in Blazor. We're going to look at JavaScript Interop in Blazor. And finally, we're going to look at authentication and authorization in Blazor. So if we go back over to Visual Studio now, I'm going to quickly talk you through the layout for the Blazor project that we're using. So by default, the Blazor project comes with all of its files divided by type, so pages and shared and stuff like that. I'm not a big fan of that for organizing applications. I find it doesn't scale very well. So what I prefer to do is use feature folders to organize my projects. So there's a features folder here, and inside of here we've got the various features of the application. So we have that dashboard we saw, the new repair screen, the view repair screen, and we've got some shared stuff as well in this shared area, things like our layout and this card component that's shared around. Also inside of here, I've got some other bits and bobs. I've got some SAS files as well, because I like to use SAS for styling, so that's going on as well. But generally speaking, the main takeaway here is this feature folder style. The other thing I want to point out is the fact that any page components, so these are components that are routable by going to a certain URL, I postfix those with the word page just to make them easier to identify inside of these feature folders. But hopefully this will all become clear as we work through the application. So the first thing we're going to do is we're going to start off on this new repair area. I'm going to open up this new repair page. So firstly, I just want to highlight, this is how we create a page in Blazor, a routable component. So everything in Blazor is a component. So this new repair page is a component. You can see any component that in a Blazor app has a .razor extension. And to make it routable, we just add this root directive, which is at page, and then the root that we want this particular component to respond to. So when we navigate to /repairs/new, this is the component that is going to get loaded. So if we go back over to the browser, we can go here. You can see /repairs/new in the browser tab here, and that's what it corresponds to in this routing template. So cool. So the first thing we're going to look at is forms and validation. So at the moment, we've got this very blank, empty page. So let's see if we can improve that to start. I'm going to paste in a chunk of code here. Now, I'm going to shrink a couple of bits because we don't really care. What I want you to focus on at the moment is this part in the middle. So essentially what I've done here is I've added a normal HTML form to the page. So we've got a form with an action, and it's going to post some data to an endpoint. I've got a label and inputs and text areas and select lists and stuff like that in here. Okay, pretty much bog standard form stuff. So I'm going to save that. I'm going to go back over to the application and refresh. Excuse me. Now what's going to happen now is I've saved that in Visual Studio, and then I come back over to the browser. If I hit refresh, that's going to trigger Blazor or Visual Studio to do a rebuild for me in the background. I haven't had to do a manual build there. And now we can see the form that we've added. So this is the various bits of information we're going to collect in order to record a new repair. We've got a name, the issue, the particular trade that needs to do that work, and a contact number. However, right now, if I hit save and try to post this form, it's going to break, okay? So it's going to try and do a post to our API endpoint. We've got the wrong media type. This isn't going to be sent as JSON. It's all wrong. So how can we make this work with Blazor? So if we go back over here, what we need to do firstly is define a model in C# that represents the information that we're going to record in this form. So the first thing I'm going to do is come down here, and we're going to add in a new field for our component. And we'll do that inside of this code block. So this code block is a place where we can add any C# code that we wish. Any valid C# can go in here. You can even define classes in here if you wish. So what I've done is I've newed up a new field with this repair model, and this repair model is being stored in this shared project. Okay, so if I open that up, this is the repair model that we're going to work with, and this just represents all that information we're going to record from that form. Okay, and as I said, it's in this shared project, which means our server project can access it as well. So now that's done, I just need to basically bind all of the HTML controls onto the correct properties on this form. So what I'm going to do is I'm just going to, again, save you watching me type all this. I'm just going to paste some code in here. So what I've done here, there we go. So what I've done here is I've added Blazor's bind directive onto each one of these HTML controls. And what the bind directive does is it enables binding in Blazor. Saying is, whatever the user inputs onto this form control, bind it to the name property on my repair model. Okay, and that's what I'm doing for all of the other controls on this form. So we've got issue, trade, and contact number. So I've done that now. The last thing that I need to do now is deal with the actual form submit event. I don't want it to actually submit using the native HTML event. I want to intercept this and deal with it in Blazor in my C# code, because then I can take that model, I can serialize it to JSON and post it to my API correctly. So what I'm going to do is I'm going to add a little method into my code block here called handle form submit. So what this method does is it uses an HTTP client, and that is being injected at the top here using this inject directive. So this is how we do dependency injection into our Blazor components. We write inject, the type that we want, and then give it its local name. So what I'm going to do here is I'm going to use that HTTP client. I'm going to post to my API/repairs endpoint. I'm going to post not my content. That needs to be my repair model that I'm going to post. Okay. And then what's going to happen if I get a successful response code back from my API, then I'm going to show my success message by just toggling this Boolean value to true. And then I'm going to reset the repair model, which is effectively going to reset the form. So just to show you as well, this is where that little success message is being shown. If show success is true, then I'm just going to show this little success message at the top. So with all that in place, the last thing I need to do is remove this these default attributes from the form. I don't need an action or a method now because I'm going to handle this in my C# code. So what I'm going to do now is I'm going to use a Blazor event. And I'm going to submit. There we go. I can spell. I'm going to use override the forms on submit event, and I'm going to say instead of that, on submit, call my handle form submit method. Okay, so that's going to stop the default event and it's going to use my Blazor version instead. I'm going to save that. I'm going to go back over to the application. I'm going to refresh the page. Again, that's going to do a build in the background. So now we've done that. If I start typing in here, so we've got John, he's got a broken tap. We're going to get a plumber in, and he's got a contact number for John as well. So we add that into our form. And if we hit save now, we now see our success message. Our new repair has been saved successfully. And if we go to our view repairs page, we can now see that that new repair has been added to our system, which is great. This is awesome. It's now working. We've now handled that form using Blazor's event system, and we've overridden all the default HTML stuff. However, our form does have a big problem. If I hit save now, it still submits successfully. And if I go to my view repairs page, you can see I've now got blank data in my API. That's not very good. I don't want bad data in my system. So what we need to do now is we need to add some validation onto our form to make sure that we can't submit an invalid form. So let's do that next. So the first thing I'm going to do is I'm going to open up the repair model, and I'm going to update this to use data annotations. Okay. So, oh, one too many. There we go. Oh, cool. If you're unfamiliar with data annotations are the built-in validation mechanism for ASP.NET Core. You can use different validation mechanisms if you wish. I'll talk about that in a little bit. But for now, we're just going to go with the defaults. And with data annotations, you basically decorate the properties on your model with the validation rules that you require. So for example, for name, I'm saying this is a required field. It must have a value, otherwise show this error message, which I've declared. For issue, I'm saying that it must have a minimum length of 10 characters and that it's also a required field. And for contact number, I've got this lovely, succinct, easy to understand, not really horrible at all, regular expression to make sure that it's a valid UK phone number because I'm based over here in the UK. So that's what I'm going to do there. So I'm going to save that. Now, actually, if I go back to the app at this point, what's really great about using .NET Full Stack is that if I try and submit this form right now, oh, I didn't do a build. Hold on 1 second. There we go. So we try this again. You'll see now I'm actually clicking right now and nothing's happening. Okay, we're not seeing that success message. And if I go into my browser tools and I look at my network tab, if I try to submit, I'm now seeing a 400, and I'm seeing that I'm now the API is now rejecting my model that I'm sending and saying that I've got validation errors. So just by adding those data annotations to that model, the API has automatically picked those up and validated the request as it came in. So the good news is now we've secured our API. Our API will no longer accept invalid inputs, which is great. But the user experience is still really bad. We've got nothing here to tell the user what's gone wrong. So let's fix that now. So over now in our component, what we're going to do is we're going to move past using the normal form element, because that's going to be a little bit restrictive for us. We're going to move over to a different component called edit form, and this is a component that is included in Blazor by default. This is a drop-in replacement for an HTML form tag, and it's basically a component representation of it in Blazor. What it does do is it gives us the ability to use these nice validation mechanisms and some other nice stuff as well. Now, in order to take full advantage of that, I've also replaced all of the HTML components with Blazor versions. So Blazor has a component version of all of the normal HTML controls. So here, for example, I've got an input text component instead of a regular input component. I've got an input text area component instead of a text area. And I've got an input select instead of a select element. And again, this works the same way. I'm binding to them using Blazor's binding directive, and I'm binding to the various properties on my model as I was before, so nothing else has changed there. And then on my edit form, all I have to do as well is to tell it what model that I'm using. So again, I'm passing it that field that we declared down here before, the repair model. And again, it exposes various events to us to handle. What's really nice though about using edit form is I can use this other event called onValidSubmit. So we were using onSubmit when we were working with the HTML form element. So we do have an onSubmit for edit form, but onValidSubmit is really nice because what will happen here is the edit form will try to validate our form before it calls our handler, and it will only call onValidSubmit if our form is valid. Now, this is really nice because what it means is our form handler, our submit handler down here, never has to worry about invalid data. The form will, this method will only get called if the model is valid. Okay, so that's really, really useful. So with that in place, all that's left for me to do really is tell Blazor what validation mechanism I want it to use to validate my form. So everything in Blazor is pretty much plug and play. You can swap anything around you want. So what I'm going to do here is I'm going to say, I want you to use data annotations to validate this form. And to do that, I include this component called data annotations validator. And this is included by Blazor by default. So because I added that, the edit form will now know how to validate my model correctly. If I wanted to use a different validation mechanism, say I wanted to use Fluent validation, which is a very popular alternative, you would just swap this data annotations validator for a Fluent validation validator. I actually have one of those in my Blazor components. And just by swapping that one component, your edit form will now use Fluent validations instead. So that's all we need. What I am going to do as well is I'm going to add one other component called validation summary. And what this is going to do is that's going to list out all of the validation errors in our form for us. So now I've saved that, I can go back over and refresh the page. We're going to get another build. And if we hit save this time, we're now seeing validation errors on our form, which is really, really nice. Now, by using edit form and Blazor's built-in form components, we get some extra stuff. So, for example, it applies a class when a control is invalid. So I've been able to use that class to style these inputs with this red border, which means also when I put in something valid, I get a valid class and I can style it to go this green color, which is really, really nice. So this is good. I can put this in. I can put my information in I did before. I can say he needs a plumber, and I can put in my phone number I had before. Everything goes green. I've now got a valid form I can submit, and I can see my valid data here in my view repairs page, which is really, really good. So that we've kind of solved all of the problems. The only thing I'm going to change, one last thing, is I just want to get rid of this validation summary because I don't really like it from a UX point of view. I think it's far better to show the errors where they occur inside of the form. So in order to do that, I'm going to remove that validation summary component. I'm just going to update all of the inputs here to use another component, okay? So this is all the same code we had before, but each one of the various inputs now has got a validation message component. And in that, I just tell it which particular property on the model I want to show validation messages for. So really simple. So I'll save that. Go back to my form and refresh. I'm going to get a build now. I'm going to hit save. And now I'm getting error messages being displayed underneath each of the fields that those error messages are for. So it's far now easier for me to understand as a user where the problem is. I don't have to keep scrolling up and down. So that's great. So that is forms and validation. We've taken a bog standard HTML form and we've progressively enhanced it now to the point where we're using all of Blazor's components together to create this nice, rich experience for our users. So that's really good. Excellent. So the next thing we're going to move on to is going to be JavaScript Interop. So in order to do that, we're going to enhance this dashboard page. We've got all of this data in our system about the various repairs that we're doing, but it'd be nice to visualize that. So this dashboard would be a great place to do that. So we're going to go back over into Visual Studio now. Excuse me. And the first thing I'm going to do is I'm going to go up into the www root folder. I'm going to go in this JS folder. I'm going to show you, I've got this chart.min.js, okay? So this is a JavaScript library called chart.js. It's a very popular library out there for rendering charts using JavaScript. And it's a good example of where using JavaScript with Blazor can be quite useful. I know the main sort of tagline, if you like, for Blazor is that you won't need to use JavaScript. And generally speaking, you can definitely do a lot without using JavaScript. But every now and then, it does make sense to do it. There's a lot of very battle-tested libraries out there in JavaScript that do jobs really, really well. And you can harness these in your Blazor apps and take advantage of all of that hard work. And really, what I like to do with this stuff is to wrap it in a C# API and kind of isolate it. And then I can just deal with it in a C# version from that point forward. And that's really what I'm going to show you today, is how you can wrap a JavaScript library in a C# API so you can kind of forget it's JavaScript under the hood, essentially. So in order to do that, the first thing we need to do is create another JavaScript file. And we're going to come down here, say JavaScript, and we're going to say, we can call this chart wrapper.js. What we're going to do with this, I'm going to pop in some code here and I'm going to shrink a lot of this down because this is all basically boilerplate code and you don't really have to care that much about it. There's only a few bits I want you to really care about here. So for Blazor's JavaScript Interop system, at least pre.NET 5, so this does change slightly in .NET 5, but we're not quite there yet. What we need an object that is attached to the global scope, so attached to the window object. So what I'm doing here is I'm creating that object. It's called Blazor repairs, and I'm kind of scoping this so that all of my functions are in this Blazor repairs object. So you can think of this like a bit like a C# namespace. So inside of here, I've got a function called build chart, and that function takes an element, and that's because chart.js needs an element in order to render the chart in. And what I'm going to do is I'm going to pass that down and create a new chart.js instance down here. I'm going to say the type of the chart that I want, which is a bar chart. And then in here, I've got the data. Now, this is all hard-coded data. I'm going to shrink it back down again because, like I said, it doesn't really matter for this point. So this is just going to display some hard-coded data just to make sure that everything is working. But the important point here is global object on the global scope, and then our functions go within it. So now I've done that, I'm going to go into the index.html page and I'm going to add in a couple of script tags now just to reference our chart.js file and our chart wrapper file that we just created. So we've done those, so we can get rid of that now, which is great. So now we've got all that in place, we can turn our attentions back to our components now, our Blazor code. So what we're going to do is this is going to go in our dashboard feature. So I'm going to go in my dashboard feature. I'm going to add a new Razor component. Okay. I'm going to call this one chart.razor. And this is going to have this is where our chart is going to render. So I've just added a few lines of code in here. I'm going to walk you through it. So first of all, I've got a normal HTML canvas element because that's what chart.js uses to render the chart. And then in my code block, I've got a field here with a type of element reference. Okay. Now, element reference is a type that's that comes from Blazor, and it represents a reference to an HTML element. In order to capture that reference, we use the ref directive, which I'm using here on this canvas, and I'm saying record the reference to this element inside of my chart container field. Okay. Now, once I've got that reference, I can use that reference and pass it down into JavaScript. Now, in order to do that, I need to do this inside of a lifecycle method for my Blazor component. So Blazor components have three lifecycle methods. They have on initialized, they have on parameter set, and they have on after render. Now, on after render is the one you want to use for JavaScript Interop because it makes sure that all of the DOM elements have been physically rendered before it's called, which means for us here, it's very important because we need that canvas element to be physically present in the DOM before we can do anything with it. So what I'm going to do in order to call my JavaScript function is I'm going to use the JS runtime. So this is this IJS runtime I'm injecting at the top using dependency injection again, like we saw earlier. And it includes two methods, invoke and invoke void async. So invoke async is used for calling into JavaScript where we're going to get a return value. And invoke void is where we're going to call into JavaScript but we're not going to get a return value. Both of these methods, their first argument is the function that we're going to call, and that's based on that global namespacing. So ours is in that Blazor repairs object, and then we're going to call build chart. So go back to our wrapper. There's our Blazor repairs object, and then we're going to call build chart. And then after that, everything is it's just a params array after that. So this is just stuff we want to pass down, and we want to pass down our element reference, which is going to translate to an element down here in JavaScript, and Blazor is going to do all that work for us. So that's our chart component. Now, if we go over to our dashboard page, what we can do now is we can replace this code here with our chart component like this. Okay. So that's what I'm going to do inside of there. I've not done anything else. So let's just go back over to our application now and see what this looks like. So excellent. It looks like our JavaScript interop is working successfully. We've now rendered our chart using chart.js, and we're getting that hard-coded data come through that I showed you, or I tried to not show you actually, a second ago. So this is great. Nice rich charting. We've got these nice hoverovers and everything showing information about the data, which is great. But as we all know, we've got hard-coded data. This isn't really very useful to us. So now let's make this more useful. So what we're going to do is we're going to come back into here and we're going to update this build chart function. So what I've done in here now is I've basically removed all of the hard-coded stuff that was in here before. So where we were setting the type as a bar chart and it was hard-coded, I'm now passing in the type. Okay, so I'm passing that in at the top here. And also we had that hard-coded data structure, which again, that is now being passed in from the top here. By the way, I didn't mention this options object, but this is just some global settings for the chart. You can, you can do what you want with those. They're basically pretty much standard, really. I've not needed to tweak those, but that's what that is because I didn't mention that earlier. So anyway, now we've got those two bits of data that were hard-coded passed in. Essentially now, everything here is primarily boilerplate code. We don't actually have anything now we need to deal with here. So we can actually save this JavaScript file off and we can close it. We don't need to come back to this anymore. What we do need to do now, though, is now we've removed that hard-coded data from the JavaScript side of things, we do need to represent it here in the C# world. So I'm going to create a new class. I'm going to call it chart data. Okay, so if I come in here, I'm going to add in, there we go. I'm going to add in this this code. And again, I don't really need you to care too much about this code, other than to understand that it's just the C# representation of that data structure that was in JavaScript. So essentially what that had was a top level object, which was a list of labels and a list of data sets. And the data set is made up of these various bits of information that are down here. But again, this is all quite boilerplate. Now we've created that, we've represented it in C#, we can close this. We don't need to worry about this too much anymore. So this is great. So this is good. So we've got all this going now. So what are we going to do in here now? We need to update our chart component for starters. So what we need to do is we need to add in a couple of parameters. So parameters are a way of defining public APIs for our components. So in this case, what I've done here is I've said anybody who consumes the chart component should be able to pass in the data they want displayed and specify the type of the chart they want rendered. So that's what these properties decorated with this parameter attribute are going to do for us. They're going to allow that public API. So now that's done, I just need to pass them down into our JavaScript function. So the first thing we did was want to pass down the type of the chart, and the other one was the data that we wanted to be displayed. So we're just going to pass that down. So that's basically it for our chart component as well. That should do us there. And then finally, we need to update our dashboard component. Okay, so I'm going to update this now. There's quite a few bits of code going in here now, but I'll walk you through it all. So firstly, here's our updated chart component, okay? And now we're passing in the data we want it to display and the type of the chart that we want it to display, okay? So now the consuming component gets to specify this stuff rather than it just being hard-coded. Inside the code block, there's quite a lot of code here, but I'll walk you through it. It's not that bad, and it makes a lot of sense once we go through. So firstly, I'm defining a field to represent that chart data that we want to pass into the chart component. I'm then using another one of those Blazor component lifecycle methods on initialize that I mentioned a second ago. And I'm using that to get the data from our API that we want to display using the HTTP client. Okay, and that was injected at the top here as before. Once we've got that data from our API, I'm calling this create chart data method and passing in the data. And all that does is construct that data object that we represented in C#. Okay, that's all that's going on there. So that probably looks a bit funky, but that's all it does, okay, in there. And once that's done, that's going to be passed into the chart component, and that's going to render that data for us. So if we save this now and go back to our application and hit refresh, hopefully now we'll see the data that's relevant to our application. And there we go. We're now seeing a list of our completed repairs and a list of our outstanding repairs, okay, based off what we've got in this view repairs page. You can see here, this is complete is basically what we're using to work that out. So this is really good. This is nice. We can see our data in a nice visual way, which is really, really cool. But what's really good about this is that now we've wrapped all of that JavaScript stuff in C# APIs. We don't really have to worry about it anymore. So if we want to change the type of chart we want to show, so if we want to show this as a pie chart, we can just change it now in this type parameter, and we can go back, refresh our app, and without changing any other code, we can now see that data as a pie chart instead, okay? And we can see that coming through nicely. So essentially, when you're working with JavaScript, all you want to do is that little bit of upfront work to model everything over into C#, and then just pass all of that configuration information down so that you don't have to work with JavaScript over and over and over again. You can wrap it once and then be done with it, which is pretty cool. So that's it really for the JavaScript Interop side of things. So we've now covered forms of validation. We've now covered JavaScript Interop. So the last thing we're going to do is talk about authorization and authentication in our Blazor app. So right now our app is unsecured. We can click wherever we want. There's no login for it. Anybody can view the data in any part of the application. So in a real world scenario, this wouldn't be true. We'd want everybody to log into our app because we'd want to know who was looking at what. And we'd probably want some permissions in here because probably not everybody in the organization should be able to see every single screen on the app because not everyone needs to do their job. So in this last section, we're going to work through those scenarios and implement them into our app. Now, the first thing we're going to do when we're dealing with authentication and authorization is secure our API, secure the server, okay? Because ultimately, anything we do in our application is going to be basically creating a nice UX. Nothing we're going to do in our Blazor app is going to create any real security. It's just going to create a nice user experience for those people because all of our application code is being downloaded into the browser, so therefore people can decompile our DLLs, they can look at what's going on, they can modify stuff, okay? So first things first, we're going to go in the server and we're going to go to the controllers and we're going to go to our repair controller. So this is what we've been using to call our data. This has got hard-coded data in it for now. And what we're going to do is we're going to add an authorize attribute onto that controller, okay? I'm not going to do anything else right now. I'm just going to add that authorize attribute. So with that attribute in place, if I go back to my application now and I try to refresh it and I try to load some data, you'll now see our chart doesn't render. If we go to view repairs, no data renders there. And we wouldn't be able to add a new repair if we tried. And that's because basically I'll open up the browser tools. We navigate around, we can see we're getting 401s back from our API. Okay, we're no longer authenticated. We're not allowed to access any of the application. So this is good. We've secured our server now. We've done the most important thing. What's left for us to do now is create a nice user experience for anybody who's using our application. So we want a login screen if they're not logged in, and we want some kind of message if they're not authorized to view a particular part of our app. So let's look at how we can do that. So first things first, we need to use an authorized attribute inside of Blazor to do the same thing that we've done on our server. Okay, so on each of the pages, I'm going to add an authorized attribute, and I do that using the attribute directive that we get from Blazor. And this is the same authorized attribute I just added onto the controller. Okay, so on my dashboard page, I'm saying you can only come here if you're authorized. I'm going to go to my new repair page. I'm going to do exactly the same thing here. And finally, on the view repair page, I'm going to do the same thing there. So we've now added those authorized attributes onto each of the pages. So this is fine. However, nothing's going to change right now. And that's because unless we tell Blazor what authorized means to our application, nothing is going to happen. Okay. Now, I'm going to show you quite a manual way of doing this because I want you to kind of see the kind of more nuts and bolts of what's going on. But I do just want to warn you up front that if you're using something like Azure AD, you're using Azure AD B2C, you're using some kind of OIDC compliant provider, or you want to use Identity, Microsoft Identity, for example, there's out-of-the-box stuff that does a lot of what I'm going to do manually for you, so you don't have to do any of this stuff, okay? But I just want to be upfront about that. I am showing you a very manual way so you can kind of see how everything fits together. Cool. So the first thing in order to get this to work is I'm going to need a provider, okay? So I'm going to start off by creating a new folder called providers, and inside of that, I'm going to add a new class. I'm calling this Token Authentication State Provider, okay? So what I'm going to do is go in here and I'm going to pop some code in like so. Now, there's quite a lot of stuff here, and again, we'll break it down and work through it all. So I'll shrink some stuff up that we don't need to worry about too much right now. So the first thing is I'm inheriting from a base class called Authentication State Provider. So the way authentication happens in a Blazor app is any component that is authentication sensitive, so cares about whether you're authenticated or not, will use an authentication state provider. And what it's going to do is it's going to call a method called get authentication state async, which we've overridden down here in our version. And basically what this method is doing is any component that calls it will get back a new authentication state, which basically says, is this person authenticated, yes or no? Okay. Now, like I said, all of these, if you're using the sort of common identity providers out there, this is all done for you. Okay. I just want to reiterate, this is me doing it manually to show you what's going on. So what's going to happen is all of the Blazor components that care about authentication are going to call this method, and we need to now tell it how to work out whether you're authenticated or not. Now, in order to do that, we're going to use Json Web Tokens. Okay. So when you log in, what's going to happen is we're going to call this this state provider we've created, and we're going to call this login method, and we're going to save the token into local storage, okay? And we're going to use a library to do that. It's one of my Blazor libraries that we're using, Blazor local storage. And that's going to just save that token in local storage, and then it's going to notify the app that the authentication state has changed. The user has now become authenticated, okay? So that's what that little login method is doing. So in authentication state async, we're going to check for the presence of that token first of all. If that token exists, then we're going to try and parse the claims that are in it and create a claims identity from that token. Again, if the token's present, we're also going to add that token to the HTTP client's authentication header, and that means it will get sent with every request that we do. And finally, once we've done all of that, we're going to return this new authentication state with that claims principal. Now, if we haven't had a token, we'll just get an empty claims identity and therefore an empty claims principal. And that will essentially mean that we're not logged in. Okay. So that's what's going on with our provider. So now we've done that, we need to add this into our dependency injection. So inside Blazor WebAssembly, we do this inside the main method of the program class. Blazor WebAssembly does not have a startup class like other .NET, ASP.NET Core applications do. So inside of there, I'm going to add some services. And I'm just going to add in a few using statements that are missing right now. So let me just do that first of all. So we'll pop those using statements in. Cool. And finally for our token provider as well. That's great. So what we're doing here is firstly, we're adding some services to do with authentication. This is just sort of regular .NET authentication, authorization services, sorry. I'm adding in some stuff to enable my Blazor local storage library to work. And then this is the bit that's kind of really important. We're doing this, we're adding our token authentication state provider that we just created. We're adding that as a scope service into the DI container. And then really importantly, we're also overriding the default authentication state provider. And we're saying for any component that asks for an instance of authentication state provider, instead provide our token authentication state provider. Okay. So that means that any component that that tries to check to see if the user is authenticated is going to get our version, and it's going to authenticate based on our rules. Okay. So we've added that in there. Next, we're going to go into the app.razor. So this is the entry point to our Blazor application. This sits at the top of the component tree. It actually contains Blazor's router. Now, by default, Blazor's router doesn't understand what authorized means, that authorized attribute. So we're going to update it now to use a different component. So by default, the root view component renders all of our components, our page components. We're going to update this to use a different one. We're going to use the authorized root view component. Now, this component requests an instance of that authentication state provider, and then it uses it to check whether we're authenticated or not when we're trying to navigate to a route that's protected with that authorized attribute. So inside of here, we can specify a template for not authorized users. So if someone's not authorized, we can say what we want to see. And in that case, we want to show a login screen. Okay. Now, login you would have seen here in this features folder. We haven't gone into it yet. There's a login component here. It's all been commented out for now, but we're going to bring that back in. And what I'm going to show you here is we've got an edit form, which accepts our user input for username and password. And we're injecting our token authentication state provider. Down in our code block, we have a handle submit method for the login form. And inside of there, we're going to post up the data from the login form, the username and password. We're going to wait for a login response from our API. If the login is successful, so the user is authenticated, then we're going to call that login method I showed you on that token authentication state provider to save our token that we're going to get back from the API. Otherwise, we're going to show an error message. Okay, so that's what's going on in the login component. Excellent. So that's what's going on with all of that stuff. So with all of this stuff in place, if I hit save now and we go back to our app and we hit refresh, hopefully now we should see, and we do, our login screen, because we now are a non-logged in user. So if I go to any page in my Blazor app, all I'm getting is that login screen because I'm not authenticated. So if I come in here and I log in as a user, I log in with my password, you can see I'm now authenticated. I can now view all of the different pages of the app because I'm now authenticated based on that logic that we prescribed. So this is great. However, what I really want to do is restrict this view repairs page to certain people because it's got personal data on it. It's got this contact number for people, which we don't really want to show that off. We only want certain people to be able to see that. So how can we go about restricting this? So what we're going to do is I'm going to close all of these down just to make this a bit easier to see. And we'll shrink these down as well. So we're going to go to our view repair page. And what we're going to do is we're going to update this card component. Okay, and we're going to pop in a slightly different component here. we're going to pop in this component called Authorized View. Now, Authorized View component is going to use that authentication state provider we created, and it's going to check based on that and based on any rules we provide. So what we're saying here is, for any of the content that's in its authorized template, only show it to people who are in the role of planner. So in order to view this particular piece of information, which is just that same table representing all of those repairs that we had before, you need to be both, you need to be both logged in and in the role of planner in order to view it. If you're not, then what we're going to do is show this not authorized content instead. Okay, so we're going to show that same card, except now we're going to show this sort of more friendly message saying that you're not able to view that bit of code. So we'll save that. We'll go back, we'll refresh the page. And now you can see we're not authorized, okay? But if I go on these various other bits, these still work. Remember, I logged in as a user, okay? So this is good. I can see the two bits that I don't have a restricted, two pages I don't have a restriction on. But when I go to the view repairs, I'm now getting my error message to say that I don't have the correct role in order to view that information. So this is good. This is really good. The problem here, though, is that right now, I can't actually log out and change into a different role. There's no way for me to do that. There is one way. I could open up the browser tools. I could go into application. I could go to local storage. I can see that I've got this Json Web Token here saved, and I could delete that out of local storage. And if I refresh the app now, I'm now back to being a non-logged in user, and I could log in again. So if I went, I'm going to log in again as my user. I don't want to log in as a user, do I? I want to log in as a planner. If I do that, you can see I can now view my repairs, and I can still view everything else because I'm now in the correct role. However, I still can't log out. This is still not a good user experience. So let's try and fix that to finish things up. So in order to do that, I'm going to go into my shared folder. I'm going to go to layout. I'm going to go into the header bar. I'm going to create a new component in here. I'm going to call this component user status. Okay. I'm going to pop some code in here. And what I'm doing, again, I'm injecting that token authentication state provider, our version of it. I'm going to use the authorized view, but this time around, I'm using it in a slightly more simplistic way. What I'm saying is, if a user is authenticated, okay, that's all they need to be. They just need to be authenticated. We don't care about roles in this case. Show them the content that's inside of these tags. So what I'm going to do is I'm going to show this nice bit of UI where I'm going to say a hi. I'm going to print out their name. And then I'm going to show a button that has an on-click handler, and it's going to call the logout method on that token authentication state provider. And what that method does, because I didn't show you that before, down at the bottom here, is it just removes that token from local storage and then notifies that the user is now a logged out user and updates everything in the UI. So that's what's going on there, okay? What's quite cool as well is in the authorized view, we do get access to information about the user. You can see here, I've got it via this context object, okay? So I can go context.user, and then I can get into everything that's going on here. So if I do dot here, you can see I get that user object. I can get all the various information I want to about the user. I'm going into identity here, but I could just go into claims if I want to and stuff like that. So that's really powerful. So if I save that, I go back over to my application and I refresh, and that's not going to work because I've done what I always do, which is forget to actually add the user component to the header bar. So if I go in here, I've got my user status like this. So we add that component in. If we refresh this now, and you can see that we now have this nice bit of UI at the top saying hi planner, and we get our logout button. We can log out, we can log in as a different user if you want to. Everything works as expected. So that's really cool. So that's basically it from me. These are some useful resources about Blazor. If you haven't had a chance to get into Blazor before, these are definitely some great places to go off and get started. But other than that, I just want to say thank you very much for watching. And I think I'm going to be going off to the experts area to answer any questions if you have any. So yeah, I want to say thank you very much for watching and enjoy the rest of the conference.